I hope you are fine. Let's start our today's lecture. In last lecture, we have discussed different types of computer. Now, and we have discussed the main components of the computer that were the hardware and the software. In this lecture, we will discuss the complete detail about these components and which type of components are used along with which type of computer. Now, as we know, the types of computer include super, mainframe, mini, multimedia, mid-range, workstation, personal computers, analog, digital, and hybrid computer. So now we have a brief introduction about that from our lecture number one. Now we will discuss the components that we might use along with these computers. So these are the general components of the computer system that almost every type of computer includes. These components are motherboard and all the components that are etched on the motherboard, processor, sound card, graphics card, internal memory, secondary storage, and external components include input devices, output devices, and peripheral devices. We will discuss all these in detail. Now, we will start from the internal components. Internal components include, first of all, secondary storage. As we have discussed the CPU and processing of the CPU, we have a little bit introduction about that. So the secondary storage is the additional storage inside the computer. When our computer is processing any data, the computer needs a memory to hold that instruction, but that kind of memory can only hold the instruction temporarily. So we need a storage that must be non-volatile, that can hold the data and when there is no electric power. As we know, the memory that is placed inside the processor or that are directly connected to the processor is volatile memory. As soon as the voltage supply cut off, all the data will be clear from that memory. So we need secondary storage so we can hold the data and we can retrieve the data and for permanent purposes. So there are many kinds of secondary storage. Each storage has its own advantages and disadvantages. And the most commonly that we must use inside of the computer, that is hard disk. Hard drive means hard disk or hard drives, HDD hard disk drive is one kind of technology that stores the operating system applications and all the things that are relevant to our computer. So we can say that that is the memory of our computer that is holding all the system software and the application software. So rest of the components in your computer work together to show your application and the files stored on the hard drive. So other components are receiving all the data from the hard disk or hard drives. So how the hard disk works? There is inside and picture of a hard disk that had a read-write head, a platter on which we are storing the data, and in one corner it includes a circuit that is responsible to store the data inside the hard disk. Now that is a structure of a platter that holds the data. The circular things are known as the tracks, and further we have to divide that tracks into the sectors. The triangle shape of the partition is known as the sector. Each track and each sector has its own number, and we are following the same procedure on the both sides of the hard disk because we are storing the data on the both sides, and both sides has each platter has its own read and write head that has a laser light in the end of that arm that is shown in that figure. That is our read write head arm, and in that arm we have placed a laser light through which we can read and write the data on the tracks and the sectors. We are dividing over hard disk because hard disk has a larger capacity, and whenever we have to organize our data on any platform, we have to make the segments, or we have to divide over a whole thing, our whole storage into the partitions, and we are giving name to that partitions, and we can store our data in a organized form. So how we our hard disk can work? As I told you, there are the platters that contains the components to hold the data like tracks and sectors. This data is your operating system application and any file that we are storing on the computer. That computer over operating system or over software will send that file towards the hard disk. So there is an arm that moves across the platter to read or write the information requested, as I have shown that arm. To make this process faster, the flutter spins as the arm moves across it. The arm will be fixed, the flutters are and the disk that is under that arm will spin faster, and the read and write head will read the data from a relevant track or the sector. First of all, it will search the track, and in the track we are locating the sector from which sector we have to read over data. So that is possible when we spin the disk, and when we locate the address, the disk stops and read write head will read the data from that particular place. So the components that hold the data can be spread out all over the hard disk. That is, data is not written sequentially. There is an indexing system like in over each and every book we have an index table in which we have mentioned the page numbers. The same phenomena is used in over hard disk. In operating system, we are making a table in which we have the information about the storage locations, at which location which file is stored. So we have the tables in startup. We are using the paging system and different other methodologies to find and store that data. So the plater and the arm are delicate, so they are covered by the steel case because we have to prevent over hard disk from the dust and other damages that can cause harm towards the letters and all the all the circuits that we are using inside the hard disk. Now, internal memory are the primary memory. That is temporary memory, and that is directly connected to the CPU. Whenever the CPU is executing something, our project the processor is executing something, our processor has to hold that instructions, and each instruction has some data. So over an instruction that must be saved in that data related to that instruction must be saved somewhere. So we have to use the primary storage. So that is essential element of a computer. If we have no storage, we will not be able to process anything because when our brain can't remember anything, our brain cannot do any task. So computer memory and the internal storage has two types: primary memory and the secondary memory. Primary memory include RAM, ROM, and the cache. These are the three types of the memory, and the secondary memory includes the hard disk that we have discussed, and DVDs, CDs, and USB drives that are also over extra secondary storage devices. So random access memory, RAM stands for random access memory. That is primary memory, that is volatile memory. I already told that what is meant by volatile memory. And we also have ROM, that is read-only memory. We can only read the instructions that is stored on the ROM, but we cannot make any change in the ROM. So that is a view of a memory. The types of memories, main memory has two types, RAM and ROM. The RAM is further divided into the SRAM and the DRAM, and the ROM is further divided into the PROM, EPROM, and double EPROM. First of all, ROM. ROM stands for random access memory. Random means we can access any address without any sequence, like the last address can be accessed before the second last address. So there is no sequence. Whenever we are pointing any address, we can access any data from anywhere. So that's why that is known as random access memory. The CPU is directly connected to the ROM, and all the instructions can be directly managed by the ROM. So all the instructions that are currently in the execution, these instructions and related relevant data will be stored on the ROM. If your over file, over program, or over instruction is not available inside the RAM, we cannot make any operation related to that. So it is volatile memory. It will lose its data whenever there is no electric power will be available. There are two types: SRAM, static random access memory, and DRAM, dynamic random access memory. SRAM as the name indicates, static RAM. It retains the data bits in the memory as long as power is supplied to it. Unlike the DRAM, which stores bit in cell consisting of a capacitor and transistor, SRAM does not have the periodically refresh. We don't need to refresh that RAM after some time. It can hold its state whenever we are working on the SRAM. Now, DRAM, dynamic random access memory, that is made by the semiconductor memory that is typically used by the data or the program code made by the computer processor. And the instruction that is most frequently used, we have to store that instructions on the SRAM, as SRAM is more faster than the DRAM because of its structure, because there is no need to refresh the SRAM after some time, but DRAM must be periodically refreshed after some time. Now, the second type is read-only memory. Read-only memory, as the name indicates, we can only read the data from that memory. We cannot rewrite the data on these chips. So, and before starting up the computer, how a computer can start, how it will hold over desktop, wallpapers, over screensavers, over date and time, all such type of instruction that is needed to start or restart our computer, to boot our computer. All that programs will be stored on the read-only memory that will help our computer for the start and restart. So that is non-volatile memory, because these type of instructions must be held permanently. And what is the problem in that read-only memory? Because we cannot rewrite that memory, so we have to use the RAM. And because the RAM cannot hold the data permanently, we need secondary storage devices. Now, the types of ROM. Programmable read-only memory. It can be programmed by the user. Once programmed, the data and the instruction cannot be changed. And although if we have made any error during the writing, we cannot reuse that disk. EPROM, erasable programmable read-only memory. It can be reprogrammed whenever we are writing the data, but only the experienced persons are the persons who are we have that have great grip on the hardware. They can erase that data by using the ultraviolet rays to reprogram that disk. Double EPROM, electrically erasable programmable read-only memory. So we are using the electronic waves to remove that data that is available in the that type of ROM. And if we want to rewrite that data, we can rewrite that instructions. So we can use this disk multi times. So mask ROM is kind of read-only memory that is masked up at the time of production. Like other types of ROM, mask ROM cannot enable the user to change the data stored in it. If it can, the process would be difficult or the slow. So only the experts can rewrite that, or only the extreme expert persons can rewrite. So and that is also kind of ROM, but that is more, that has more quality as compared to ROM. So in MP-ROM, so we cannot make changes, but there is a chance to write the instructions in that, but that methodology is slow and difficult. Now, cache memory is chip-based computer component that retrieve data from computer's memory. So whenever we have to store the most frequently used instructions, as the cache memory is faster than the RAM, so we place another memory inside the CPU and the RAM that is known as the cache memory. So we are storing the data that is most frequently used inside the cache. So whenever the CPU needs any data, it will go towards the cache. If the data find in the cache, and then the processing will be continued. If there is no data relevant to that instruction in the cache memory, the CPU has to travel towards a RAM. Then if there is no data, then the CPU will go towards the hard disk. So whenever we have to work on the speed, we have to store that instruction in the cache memory. So the cache memory, sometimes called the CPU memory, because it is typically integrated directly into the CPU chip or placed on the separate chip that has a separate bus interconnected with the CPU. So that memory is close to the CPU. In order to be close to the processor, cache memory needs to be much smaller than the main memory. Registers are the memory locations that are placed on the processor chip. So it can hold only a simple amount of data. There are 32 or 64 registers. Each register has its own purpose. Some registers are used to accept the data, store the data, or some are used for the other purposes. Some are used to store the addresses. So they are the most the fastest memory inside the computer. So because that is based on the CPU chip. So the computer needs processor registers for manipulating data and a register for holding a memory address. So that is hierarchy of the memory. The fastest memory is registers, then cache, then main memory, or the RAM, and then hard disk. And the CDs, DVDs, and USBs are all slower than the hard disk. Now, processor. The processor is the brain of computer. So the processor is a piece of hardware that interprets the instructions that drive a computer. Processors are brain of computer with good reason. Without a processor, computer could not run any program. Each and every type of processing will be done inside the processors. So these are known as central processing units. It will take the instructions from the input devices and the RAM can hold these instructions. The CPU decodes and processes an action when an instruction is received, and then the CPU will delivers an output. There are the three components in the CPU: arithmetic, logic unit, control unit, and memory unit. So the ALU can do the logical operations as well as the arithmetic operations like addition, subtraction, multiplication, division, less than, greater than, less than equal to, greater than equal to. Comparison can be done by using the AL. Now there is the register. The registers hold the instructions received from the other parts of the computer. It tells the ALU what processes to carry out and stores the result of those operations. So the instruction is also held inside the register and the data related to that instruction will be held by the register. So processor include the L1 and L2 memory. This cache of the memory allows processor to store the data locally without having to retrieve it from the RAM. So we have two levels of memory, the L1 and L2. These are the cache memory. The presence of this component help to do over task more faster. Now that is a processing cycle of our CPU. There are different steps in that. First of all, we have to do the fetch, then decode and execute. Fetch means we have to take instruction from the input devices. It involves receiving or fetching the instruction, and these instruction will be sent from the RAM to the CPU. Now decode, as we know, the computer's language is 0, 1, and the computer only understands 0, 1. So we have to decode over instructions that is received by the RAM in the form of the 0, 1. So the CPU processes an instruction using the decoder when it's sent from the instruction register. The CPU turns the instruction into a series of signals that can be interpreted by the other parts of the CPU. Now execute means doing the operation according to the instruction. Now the CPU knows what to do and how to do. So at the end of the process, the computer executes that decoded instructions. Instructions are sent to the other parts of the processors to be executed. Like if we have to do the addition operation, the instruction will be sent to the ALU. The CPU register saves the instructions after the execution for the result. So this helps to improve the speed of processor because it can remember some instructions. It has to be processed. Now, motherboard. Motherboard is the main component of the system. Like all the components has to be edged with the motherboard. So that is also known as the circuit board and the computer system, also called the logic board or the main. So in the computer system, the biggest component is the motherboard that controls all the components of the computer system and establish a link between all the components. All the electricity will be provided by the motherboard. So from the motherboard, different components like ROM, CPU, RAM, slots, USB ports, and other components are connected. So that is a platform through which all the components can communicate with each other. Now, basic components of the motherboard: ports in which we are placing our peripheral input and output devices. These are known as the ports. Port is a physical pointing using which the external devices can be connected to the computer. A port has the following characteristics. External devices are connected to a computer using a cables and the ports. Ports are the slots from the motherboard into which a cable of external device is plugged in. Like for mouse, we are using different type of port. For keyboard, we are using different type of port. For microphone, we are using different type of ports. So each and every external device will be connected by using these ports. So ports are the slots in the motherboard into which a cable of external device is plugged in, like a switch is available inside cable circuit. So examples of external devices are the mouse, keyboard, monitor, microphone, speaker, etc. Now, there are different types of ports available. Serial ports used for external modems and older computer mouse. Two versions are available, 9 pins and 25 pins are available. Data transfer rate was slow, that is 115 kilobytes per second. But nowadays we are using USB port for most of the devices. Parallel ports are used for the scanner at printer, as these are the faster ports as compared to the serial ports. It has 25 pins, so all the devices that need fast transmission, like um, monitor, printer, and scanner, we have to use the parallel ports for these devices. PS to port used for old computer keyboard and mouse, also called the mouse port. Most of the old computer provide two PS2 port, each of the mouse and the keyboard. There are the two ports available in the backside of the computer. Now, universal serial bus are the USB port that is most commonly and the faster port that is we can use inside the computer. It can connect all kind of external USB devices such as external hard disk, printers, mouse, keyboard. Most of the components provide two USB ports as the minimum, and we can extend these ports data travel at 12 megabits per second. So these are the faster ports. VGA ports connects monitor to the computer's video card. It holds 15 holes similar to the serial port connector. However, the serial port connector has pins, but now we are using the holes. And in the switch, we are using the pins. Power connector, three now plug connects the computer's power cable. Um, as we know, these power cables has three pins through which we can attach them. Modem port connects a CPU modem to the telephone network. Firewire ports that transfer large amounts of data at very fast speed. Connects camcorders and the video equipment to the computer's data travel at the 400 to 800 megabits per second. Invented by the Apple, it has the three variants, 4 pin, 6 pin, and the 9 pin. So each and every port has its own purpose. Ethernet port, to which we can connect over Ethernet cable, that is nowadays are using for the connection of the internet. So the connects to the network and the high speed internet connect the network cable to the computer. This port resides on a Ethernet card. Data travels at the 10 megabits to the 100 megabits per second. Now the game ports that are used to join the joystick with the PC, but nowadays we are using the USB port. Most of the ports are replaced by the USB ports. Digital video interface DVI port connects the flat panel LCD monitor to the computer's high-end video graphic card, very popular among the video card manufacturers. Sockets connect the microphone and speakers to the sound card of the computer.